have just witnessed a shockwave in the skies. China's White Emperor has arrived. A fighter so mysterious, so advanced, it's ignited fierce comparisons with America's most secretive jets, the F-22 Raptor and the Next Generation Air Dominance program. Experts across the globe are dissecting every pixel of footage, debating its speed, stealth, and firepower. But the real question is, can this new Chinese marvel truly challenge America's air supremacy and shift the balance of power in the skies for decades to come? As tensions between Washington and Beijing grow sharper, the race to dominate the sixth-generation battlefield has reached a breaking point. Both superpowers are pouring billions into creating aircraft that could rewrite the rules of aerial combat. The United States is betting big on its next-generation air dominance program, a revolutionary system that blends manned and unmanned aircraft, adaptive engines, and near-invisible stealth with unmatched sensor integration. Meanwhile, China has unveiled its answer, the White Emperor. Revealed to the world at the Zhuhai Air Show, it's not just a new jet. It's a statement. Reports from Chinese state media claim it can operate not only within the atmosphere but also in near space. A bold move signaling Beijing's ambition to control every layer of the sky. Whether exaggerated or not, one thing is clear. China's military modernization is advancing faster than anyone expected. Images and footage show a sleek, delta-shaped aircraft with deep internal weapon bays, capable of carrying heavy ordnance without sacrificing stealth. Analysts point out its razor-sharp nose, smooth contours, and multi-layered cockpit canopy, all precision-crafted to minimize radar and infrared detection. Every design choice screams next-generation stealth and high speed. Dominance, its advanced thrust vectoring. Engines and restructured fuselage reportedly grant it supermaneuverability, on par with the F-22, a critical edge in close air combat. In such scenarios, every millisecond counts. A jet that can twist, roll, and outmaneuver missiles isn't just surviving, it's ruling the fight. The White Emperor's expanded internal weapons bay gives it flexibility across missions, from air-to-air duels and ground strikes to near-space operations. It's designed to be one machine that can do it all. And then there's the game changer, directed energy weapons. Integrated lasers reportedly allow it to engage multiple targets simultaneously, vaporizing threats in seconds. This marks the dawn of a new kind of warfare, where stealth, speed, and precision energy weapons work together as one unstoppable system. Reports from China Arms indicate that the White Emperor isn't just a prototype. It's already taking to the skies in test flights. Its aerodynamic shape minimizes drag, enhances stealth, and maintains stability at supersonic speeds. Its advanced canopy shields the pilot from detection, while its delta wings provide exceptional agility. Inside, everything is networked. Sensors, weapons, and avionics fuse data in real time, allowing pilots to make instant tactical decisions. The aircraft can fight alone, or as part of a larger digital swarm with unmanned drones acting as its wingmen. Artificial intelligence drives its core, not as a gimmick, but as the fighter's brain. It processes threat data faster than human reflexes, prioritizing targets and assisting the pilot in executing maneuvers with deadly precision. The pilot becomes the mission commander, guiding an intelligent war machine that thinks, reacts, and adapts mid-battle. This isn't science fiction. The U.S. Air Force has already tested similar technology with its X-62 Vista, where AI controlled a jet in live combat scenarios. Now, China seems ready to bring that same level of autonomy to operational fighters, marking the moment when machines begin to think and fight alongside humans. In combat, seconds decide victory or defeat. With the White Emperor, those seconds could belong to whoever can fuse intelligence, stealth, and power into one lethal force. Design prioritizes artificial intelligence not just for tactical maneuvering, but as an integral component of multi-unit worked combat. In practice, this means the White Emperor could seamlessly integrate with other fighters, drones, or command and control systems, exchanging data in real time, and executing coordinated strikes across multiple domains. It is a concept that mirrors and perhaps seeks to outpace the United States Air Force's vision for its own next-generation air dominance program, where manned and unmanned systems are designed to operate as a single cohesive force. By integrating this level of autonomy, China is signaling its intent to compete not only in the development of stealth, propulsion, and weapons technologies, but also in the field of digital warfare. The White Emperor could potentially reduce the need for continuous human oversight in high-risk missions, sending unmanned or semi-autonomous units deep into contested airspace where survival odds for a pilot would be minimal. This possibility represents both a technological leap and a strategic shift, moving warfare into an era where decisions are increasingly made by machine intelligence guided by human objectives. The White Emperor is built to be far more than a single-purpose aircraft. Its designers envisioned a machine capable of adapting to nearly any role on the battlefield. This fighter is intended for multi-role missions, able to take on air-to-air engagements, air-to-ground strikes, and even operations in what China claims are near-space environments. Embracing this range, it attempts to cover multiple mission types with one highly adaptable platform. Such flexibility reflects China's broader ambition to field aircraft that are not only powerful but also versatile, enough to meet unpredictable combat demands. A major reason for this adaptability lies in the White Emperor's modular systems. Unlike older aircraft that require significant modifications for new missions, the White Emperor can be configured quickly for different combat scenarios. This means the jet can transition from conducting deep strike missions to performing air superiority patrols with minimal delay. In practical terms, this versatility allows China's Air Force to deploy fewer aircraft while still maintaining coverage across a wide variety of missions. By reducing logistical strain and increasing readiness, the White Emperor strengthens China's ability to conduct long, sustained campaigns without exhausting its resources. Equally important is the emphasis on maintenance. AVIC designed the White Emperor with low maintenance requirements in mind. Traditional fourth-generation jets often suffer from long downtimes after missions, but the White Emperor promises high availability with minimal turnaround time. For prolonged operations where every minute matters, this capability ensures the aircraft can stay in the fight longer and return to the skies faster. It is not just about performance during combat, but also about endurance over the course of days, weeks, or even months of deployment. Where the White Emperor truly shows its futuristic intent is in its networked warfare capabilities. The jet is not meant to fight alone. Instead, it is designed to integrate seamlessly into China's future combat networks, linking up with other aircraft, ground units, and even naval forces. Such interconnectivity transforms the jet from a single war machine into a node in a vast coordinated system. This concept mirrors the approach of Western programs, such as the United States Air Force's Collaborative Combat Aircraft Initiatives, where drones and manned jets work in harmony. By being able to communicate in real time, the aircraft expands tactical options on the battlefield. Pilots can receive live data from drones, pass targeting information to ships, or coordinate with ground-based missile systems. The effect is a wider, more unified battlefield picture, enabling swifter decision-making and more precise strikes. The South China Morning Post emphasized this point by noting the jet's networked capability allows coordinated actions with diverse units, reinforcing China's bid for air superiority. Artificial intelligence plays a central role in this network vision. The White Emperor's onboard systems are designed to process massive amounts of data in real time, filtering and prioritizing information for the pilot, or even handling coordination autonomously. When combined with drones and ground units, this creates a combat environment where China's forces can act faster than their opponents, tightening the decision loop in their favor. Taken together, the White Emperor's operational flexibility and networked capabilities highlight China's determination to dominate future battlefields. By merging adaptability, endurance, and interconnectivity, the aircraft is presented as a cornerstone of a larger vision, one where Chinese forces can seamlessly coordinate across air, land, and sea, maintaining the upper hand in complex, high-intensity conflicts. Unlike traditional fighters, the White Emperor is often described as more than an aircraft, standing somewhere between a combat jet and an aerospace vehicle. Its rumored ability to operate at near-space altitudes marks a fundamental shift in how air dominance might be defined in the future. Reports have emphasized that China's defense industry wants to achieve a qualitative leap that challenges existing superiority dynamics. According to the National Interest, the White Emperor series could reshape contested airspace by bolstering China's ability to project power far beyond its borders. If realized, such an aircraft would not merely match foreign developments, but could redefine them, forcing adversaries to prepare for combat environments extending into the stratosphere. Although details remain scarce, particularly in English-language sources, Speculation paints a picture of the White Emperor is believed to be capable of reaching top speeds near Mach 5, translating to almost 6,000 km per hour and covering operational ranges beyond 4,500 meter. Its ceiling is claimed to extend past $100,000 FT, placing it within near-space territory where traditional air defenses lose much of their effectiveness. These numbers alone, if proven accurate, would mark the White Emperor as a once-in-a-generation leap in aerial engineering, setting it apart not only from fifth-generation fighters like the F-35 or the J-20, but also from projects aimed at the sixth generation. The role of artificial intelligence is perhaps the most revolutionary aspect. Instead of simply assisting the pilot with navigation or weapons targeting, the White Emperor is expected to function with full autonomy when required. Real-time decision-making, data assessment, and threat prioritization could all be handled by onboard algorithms, giving the jet an option to operate as an unmanned system. Such autonomy would not only reduce risk to human pilots, but also allow the aircraft to push beyond human physiological limits, especially in high-speed, high-altitude engagements. In parallel, its weapon loadout, which is rumored to include hypersonic missiles and directed energy lasers, would give it the capability to strike with both overwhelming force and precision. Another significant factor is the promise of minimal maintenance requirements. If China's designers succeed in reducing logistical burdens, the White Emperor would not only be more powerful than many of its rivals, but also more available, spending less time grounded and more time deployed on missions. This would give the PLAF a considerable operational advantage in a drawn-out conflict where rapid redeployment and sustained pressure are key. Much like the NGA fighter, the White Emperor is expected to operate alongside unmanned systems with loyal wingman drones, serving as expendable extensions of the manned aircraft's operational reach. In the NGAD framework, collective combat aircraft or CCA drones accompany the main fighter, reducing the need for larger quantities of manned aircraft and lowering program costs while providing unprecedented battlefield flexibility. The projected timeline for China's sixth-generation fighter calls for operational deployment by 2035, which means a functional design must emerge before the end of this decade, placing significant pressure on designers and engineers. The United States, however, appears further along in the program, integrating advanced adaptive engines, AESA radars, and networked sensor fusion to create a versatile and stealthy aerial platform capable of dominating contested airspace. On the 21st of March 2025,